We're going to look at free body diagrams number 1. So we're trying to draw free body diagrams for these objects in each of these situations. I'm going to draw without system schemas, but if you need to, please draw the system schemas. If you're ever at all in doubt about what forces are acting, go ahead and draw a schema. Okay, object lies motionless. The only things it's interacting with are the table and the earth. So the table is exerting a normal force up on it, and the earth is exerting its weight down, the gravity force, the weight down, mg. Okay, 2, the object slides at constant speed without friction. Again, the only objects it's interacting with are the table and the earth. And because there's no friction force, the only force that the table is exerting is a normal force. So that velocity that's on there is not in the picture. Motion is not depicted in the graph here. Only forces, or in the diagram, only forces. All right, 3, the object is slowing due to kinetic friction. Again, it's interacting with the table and the earth. So that earth force is the weight, and the table is both pushing it up with normal force, and friction is resisting that motion. So the motion is to the right, so the friction is to the left, and we're going to call it F sub k for now. We'll figure out a better expression for that force later. Okay, object slides without friction, so it's speeding up going down the hill here. It's only interacting with the incline and the earth. So the earth, there's the weight down, and this is a normal force here. So if the incline is like this, the normal force is perpendicular to that. Okay, drawing the incline in with a little dotted line is a great idea. All right, static friction prevents sliding. Again, it's only interacting with the table and the earth. So mg is going down. Again, we have a normal force that is perpendicular there. But this is a case where there would be sliding if there were not static friction. So static friction is preventing the motion that would happen. That motion would be down, which tells us that static friction is pulling up. And we'll call that F sub s. Object suspended from the ceiling. It's interacting with the rope and the earth. So the weight is the force the earth exerts on it, and tension is the force the rope exerts on it. It's not touching the ceiling at all, so there's no force from the ceiling. Here an object is suspended from the ceiling. It's interacting with 2 ropes and the earth. So the weight down, and then I have 2 ropes. Each tension force here, they may not be equal, but they may be. They are actually equal here. But if you don't know that, go ahead and name them different things. Each tension force is parallel to its corresponding rope. All right, object is motionless. It's interacting with the earth. It's interacting with this rope, and it's interacting with that rope. So that's an mg down. That's a tension to the right, and then there's a tension at an angle to the left.